Hi all. In this session, we are talking about Grakn database. So, what is this Grakn database and why it is more popular than other databases what we have in market now. So, this Grakn abbreviates graph knowledge. Okay, graph knowledge has been abbreviated short form as Grakn and dot artificial intelligence. Okay. So if you look at the analysis part of this Dragon database, why we are using this in the present trend. So nowadays, the amount of biological data available online has grown. That means basically this graph database is required to analyze the data scientist data analysis a part which they have done on a product experiment. So the amount of biological data available online, if you want, you can check it in the online research kit or where it has all online research data available. So it is smoothly, the over the course of period, it is growing and it is having a bulk of data, but this has been accompanied by enormous challenges so arising from the need to integrate and connect related information from online. So because the data is being getting from different sources, the if you look at like common problems include locating resources, different data formats or ambiguity and duplication because you are getting data from different databases, different locations. So relationship between data and the volume of data, generally growing it. And because when you start doing an analysis on particular research, whether it may be health related or whether it may be education related or it may be some other part. So when you start doing of this, you will get a lot of stuff from different sources and different locations with different format of data, and basically sometimes you may get duplicate data. So when you start integrating these all data, you know you have a lot of problems. So that is what we are talking about now. There is no standard memorization and query format for this kind of data. So each resource usually requires a different approach to be properly handle this biograph knowledge data, right? So biological data is nothing but it's a natural process, a natural science that studies the life and the living process of organism. This is what biological definition I can say in some different way, because we have different meanings, different definitions for biological word. But simply I can say this is the study on life and living process of an organism. Okay. That means it including the physical structure or chemical process or molecular interactors. So based on several factors, they are counting when they are doing a process on the life of any organism. That is what biological data. Okay. So we have a lot of databases with respect to this graph knowledge databases. Anyway, the existing databases Oracle and SQL Server or NoSQL, etc., are not suitable for graph knowledge database, because when you start fetching of data, it will fetch the data and show you on some tabular format, but not give you any semantic way or ontology kind of relations and the rows, etc. It won't give you. If you want to get any relations in constraints, again you have to fetch with some other different query. Okay. When it comes to Grakn, we have everything available. So because when you fetch the data of any entity, it will give you a graph format where it shows you all relations and all constraints and everything in the semantic format. That is what I can say in the ontology structure. So ontology is nothing but the philosophical study of being. More broadly, it is showing your data. That way, the data scientist can be knowing that the relations between the entities and the attributes uh, in standard format, so they can easily identify the relations and the going forward approaches for specific research, right? So why they have chosen Grakn? Basically, this Grakn is an open source framework, and it is a main database for artificial intelligence. It is a detective database in the form of knowledge graph that uses machine learning to simplify the data processing challenges for artificial intelligence applications. Okay, so when you talk about more on this Grakn AI, this is provides knowledge information for cognitive and intelligent system. That means it has its own self microservices and inbuilt using Apache server. So it has been developed on Java platform. So it has its own cognitive and intelligence services to provide the information on UI in the format of semantic format. Okay, so it is an evolution of the relational database for highly interconnected data, as it provides concept level schema that fully implements the entity relationship model. I can say this is the evolution of RDVMS, where the system is going to connect with highly interconnected data and huge amount of data with some concepts and the relations. So high level integrated, highly the huge amount of data with the concept level schema that fully implements the ER model, entity relationship model. So this Grakn provides the knowledge foundation by providing an intelligent language for modeling and transactions and analytics. So being a distributed database, so we have a benefit when you use this on network process with multiple users, but scaling and performance, etc. So that way we can say this is one of the most popular database for graph and situations and contexts, because it has sharding and it has replication features. It has the uh, different features and different languages inbuilt in with this Grakn. Because basically in the Grakn architecture we have two layers, whereas storage and the processing. In the processing aspect, we'll use the GQL statement in GraphQL language. That is GraphQL statements which are being processed on GraphQL language, and another one is Grakn storage, where the entities and data sets are being stored. So there are limitations actually with the existing database. That's why we are going with the Grakn database. So if you look at the traditional databases, it used to show in the tabular format, right? When you look at the Grakn, it shows you in the graph format. That is graph knowledge. That means if you look at this is my entity. You can say in the table where I have these are the attributes: region, district, city, country, content, language, concept, and this particular concept have these relations: has district and has continent, has city and speaks and has region, and this concept again have resources these. That means my particular biological data of this entity is coming from different sources and which has different relations and which has different attributes, right? So when you fetch the relevant entity, it shows you the graph as similar to this one. So that I will be knowing, as a data scientist, I will be knowing that this entity data is coming from these many resources and this attribute having these many relations and this entity having these many attributes. Such a way, it is giving full graph knowledge, and no need to again fetch the database for finding and knowing of associations between the entities and the attributes and the the roles. So in the single shot, you will get all the information and show you on the graph format. That way, it is very easy for understanding the data scientist. Okay, so that's the reason I said it is the evolution of RDBMS. Okay, so why we choose in this the Grakn AI? Because as I told you, this is one of the reason. And second reason is there are several limitations on the SQL format that prevent it from expressing the semantic of data. That's right, we have to agree with that, because there are different limitations in the existing databases, because it is preventing to express the data in the graph format, because we don't have that much of flexibility in the commands to show the data on the graph format, right? And by this semantic, I mean this meaning of the data connect easily be encoded alongside the data itself. I can say in the contrast, a knowledge graph is self-descriptive, or simply put it provide a single place to find the data and understand what it's all about, right? So when I say this is a single point, actually single query, I just ran it. So it is giving all the relations on all this stuff. When I click on this, it will give you the data itself. I will show you in the next session. So how we are going to create this database and the key space and the entity and the attribute and how the data is fetching. You will see in the later sessions, because the session is only concentrating on the introduction part of Grakn database. Okay, so this is one more limitation, because we don't have any syntax and the command for getting the data, the graph format and the existing databases. Okay, uh, and because of these reasons, so we have to go for different databases, Neo4j or Grakn DB, Bio Graph DB, and this is one of Grakn.ai. These are different databases we have in the market, but it has different features when compared to other databases, because it is dealing with the huge complex data models. Okay, and also it has a partitioning feature and it has replication feature. One thing I tell you that whatever database it is supporting sharding, that is partitioning of your database, like master to master and master to slave, it is going to give more performance compared to another database which is not supporting sharding and partitioning part. Okay, so like this is what the architect, I mean the complete semantic format this Grakn database is giving you the results on the graph UI. And to process this, we used to write a query. That query is called as GraphQL query, GQL statement, Grakn language statements, like SQL statement, structured query language. So in GraphQL, we refer to the body of the rule, like different rules, when and then kind of thing. We'll look at all these things. And when it comes to here, I told you this is having the ER model, because this is evaluation of RDBMS for highly interconnected data, as it provides a concept level schema and that fully implements the entity relationship model I told you. So in the ER model, so this is what the keyword we are going to use to create a table. This is entity, like this is defined, and here person is my entity and sub entity. So this is the keyword entity, and this is the reserved word sub. And when I say this is entity, it is entity. Okay, person sub entity has a name, place, employee. So these are the actually these are the roles. Actually, it has a name and it is play role as an employee. So, and here in comes to this company entity, it has a name and close employer. Okay, this is a role is employee, and this entity role is employer. If you look at the relation between these two, the roles, so we have relates employee and relates employer. So this is the syntax of creating the entity relations between entities. And this is the last one is about attribute, like what kind of attribute you are defining. So in this case, I define name, so of type data type string. So once you write this query and run it, you have to run another command commit, which commits your the query results into Grakn storage. So this is all about ER model, like how the entity relationship happening in the Grakn database. If you look at the types, so as I told you, like let us say like my person entity has two fields. This is attributes, first name and last name, and student is another entity in the part of person, and undergraded is another entity and part of student, and postgrad is another, and I mean another entity and part of a student, and teacher also another entity of person, supervisor is another entity of teacher. This is what the the uh, inner level of entities. So my parent entity is a person, actually it has first name and last name, but this person again have a sub entity student again have undergrad and postgrad. Your teacher is again a sub entity of person, but teacher may have under this supervisor and professor. So Grakn types provides easily and quickly model type inheritance into a knowledge model. So this is what the principle it has. This allows data types to inherit the behavior and properties of their parent. So here, if you look at this, these things are being inherited to the student, and student things are inheriting into upgrade, undergrad, and postgrad, and here teacher is inherited to supervisor and professor. This is what the relation and the types being imported and inherited into parent to child. Like function in programming, rules can chain themselves to one another, creating abstractions of behavior at the data level. So, and when coming to the rules, we can create different kind of rules for different entities in the Grakn DB. Let us say like I'm just creating a rule. So please note that define keyword is a common for all kind of syntaxes. So define, this is what my rule, and sub is the reserved word, and this is the rule keyword for creating a rule. So it has basically two things. This is like LHS and RHS. So LHS have a keyword when, where you can specify the conditions here. Like in Grakl referred the body rule as when of a rule, that means antecedent of the implication, and the head as then of the rule. Okay. So in this when I mentioned that like we define the rule object as located X and locating Y. When you located X, definitely indirectly locating Y. And when you locate the Y, it is indirectly locating Z. So when these two conditions are true, so definitely what happens is the action will be located X is going to be give Z. That means when you locate X, it is going to give you the Z thing. So this is how we are defining rules in the Grakn database. So like if you define like a parent and ancestor entities, so we can specify parent child as a partnership, and ancestor descendant is the ancestorship. Then we can specify role as parent. When you search the parent, then it will automatically give the ancestor descendant relationships as well. So this is how we are going to create the Grakn the rules. So when I say the dotted things, if you look at syntaxes of any rules here, so when a keyword of the rule is required to be a conjunctive pattern, where the then should be a atomic container as a single pattern. If your use case requires a rule with a disjunction, like the when part, please notice that when using the disjunctive normal form, it can be decomposed into several or series of conjunctive rules. So we can define multiple conjunctive expressions also in the when part, and that's all depends on the requirement. So this is all about creating a entity and creating a relations and creating a rules in the Grakn databases. So how we are going to set up, or how we are going to start our Grakn DB in our local, that we will look into the next session. So after that, we'll look at the creation of the database. You can say this key space in Grakn, and entity and attributes. Okay. So thanks for listening to this video, and please subscribe this YouTube channel for more videos on Grakn. Thank you.